Whenever we have two ratios or rates that are equal, we have a proportion. The most common usage of proportion is when we have two changing quantities that are related in such a way that the ratio doesn't change. So a proportion states that two ratios or two rates are equal, like A over B is equal to C over D. The A and D are called the extremes, and the B and C are called the means. So you can think about colon notation where A to B is equal to C to D. Anyway, in any proportion, the product of the extremes is equal to the product of the means. And this is what's called a cross product. So in symbolic form, if A over B is equal to C over D, then A times D is equal to B times C. So when you have a proportion, the first step is to set up the cross products, equal to each other. And then isolate the variable, simplify the answer if possible, and when you have time, check your work. So, example 1, what number is to 10 as 6 is to 15? So we can think of our number to 10 is equal to 6 to 15. So we have n over 10 equal to 6 over 15. So the cross products would be n times 15 is equal to 6 times 10. So we'll have 15n equal to 60. And the way we solve for n is to divide both sides by 15. So n would equal to 4. So what we have here is 4 over 10 is equal to 6 over 15. And if we check, 4 times 15 is 60. 6 times 10 is 60. So it looks like it works. All right, so let's solve for x in this equation here, this proportion. The cross products would be x times 30, so that would be 30x equal to 10 times 15. So 30x is equal to 150, and then I would divide both sides by 30 and end up with x equal to 5. So 5 over 15 is equal to 1/3. 10 over 30 is equal to 1/3. So a third. So you can see that these two are equal. Or if you look at the means and extremes, 30 times 5 is 150. 10 times 15 is 150. So the cross products are equal as well. So say I have 2 4/5 to 1 1/3 equal to 3 1/2 to x. Now, mixed numbers really don't work well when it comes to division or multiplication. So let's rewrite this all into improper fractions. 2 4/5 would be 2 times 5 is 10 plus 4 would be 14 over 5. 1 1/3 would be 3 plus 1, so 4/3. Equal to 3 1/2 would be 6 7/2 over x. So in terms of cross products, we'll have 14 over 5 is equal to 7/2 times 4/3. 14/5 x is equal to 7/2 times 4/3. And the way we solve that is I'd multiply by the reciprocal. So instead of 14/5, I'd multiply both sides by 5/14. So what will happen on the left is we'll be left with x equal to 7/2 times 4/3 times 5/14. So 7 goes into 14 twice, and 2 times 2 goes into 4 once. So it looks like we're left with x equal to 5 over 3, which is 1 2/3. The scale of a map indicates that 1 inch on the map corresponds to an actual distance of 25 miles. So we can say that 1 inch corresponds to 25 miles. If two cities are approximately 2.5 inches apart, so I'd put that in the numerator to make the units match, what is the actual distance between them? So that's going to be my unknown. So using these rates, 1 inch to 25 miles is equal to 2.5 inches to x miles. So if I do the cross products, 1 times x is equal to 25 times 2.5. So x would be multiplied together. 25 times 25 is 625. So 25 times 2.5 would be 62.5 miles. And finally, a recipe calls for 2.5 cups of flour and 4 eggs. So 2.5 cups of flour goes with 4 eggs. If only 3 eggs were used, and I'll put that in the denominator so my eggs match up on the denominators, then we want to figure out how many cups of flour should be used. So I'll make it x cups at the top. So what we have here is 2.5, which again, it's better to use improper. So that'd be 4 5/2. So we have 5/2 times 3 is equal to 4x. So what we have here then would be 15/2 is equal to 4x. So I would multiply, you can think of it as 4 over 1. You multiply by the reciprocal 1/4 on both sides. You'll have x on one side, and the other side would be 15 over 8, which would be 1 7/8 cups.